Okay, let's talk about sine, cosine, and the unit circle. So let's talk about the unit circle, and the unit circle is it's a circle with a radius of 1. Okay, and the idea is that we're going to take a point on the circle and we're going to move it around, and we're going to, define sine and cosine and tangent. A couple of things though. Let's just start with something basic. If we have x, y here, First of all, if I take xy, and reflect it over the line y equals x, we know we have the point yx. That's the first thing you need to know. Second is, we have a point on the unit circle, and if I take the points x, y, right, and I rotate it 90 degrees, it becomes, we flip it and negate, like the reciprocal. So it ends up, kind of like here, a rotation of 90 degrees, it ends up here, negative yx. Yeah, flip it and negate. So these are two things. Okay, keep these in mind. Once again, there's a point, we're moving along the unit circle. Okay, so once again, we saw in the last class, we talked about radians, and we saw that in a unit circle, my camera's off. Sorry, in a unit circle, we have a radius of 1. So this is kind of cool. So the question is, we saw that we can measure this angle by using this part of the circle, this arc, and that's kind of cool, right? So if we say that, for example, let's say that's a 45-degree angle. Well, in a unit circle, let's say we start at 45 degrees, and the question is, turn that into radians. And so, you can say, okay, well, 45 is part, but we don't use degrees anymore. We want to use like actual numbers. And so you said, fine, 45 is an eighth of 2 pi, or pi over 4. And so we can say, you know what? Instead of saying 45, we're now going to say this angle measures 45 degrees. So what's cool is the arc is the angle. And I kind of I started off in the unit circle, but we can have any single, angle and an arc. It doesn't matter. And we know from the example, so for example, if this is 1 and 1, and we measure this arc to be like pi over 7, the measurement of this angle is pi over 7 radians. And we saw from the formula, for example, here's another angle, completely separated from a circle, and we have, an arc measurement, and let's say the radius is 3, and once again, this is going to be like in a circle. Remember, that's where it came from. And I don't know, 3 pi over 8. And so the question is, what is the measurement of this angle? And you say, okay, Mr. Adler, theta equals 3 pi over 8 divided by 3. This angle measures pi over 8 radians. So that's the idea. Now, once again, let's bring it back to the unit circle. We're lucky because we made the radius of 1, which means the degree of the angle is equal to the subtended arc. We're going to use that. Okay. So we're cool there, right? Now, let's move on. Well, there's a point here, right? There's a point there, right? So I'm going to erase this. There's a point. Well, I'm going to leave the theta in there. And a point that from original geometry, right? We define a point by its x and its y coordinates. Where's the cap to my pen, right? So what's the x coordinate? This is the x, and this is the y, right? Every single point can be defined by that x, by that orange x and that green y. Well, it turns out that this actually is the cosine of theta, and it turns out that sorry. This is the sine of theta, and this is the cosine of theta. And this is how we're going to define sine and cosine in regards to the unit circle. Sine is the height of the point as it goes around the unit circle. So sine, the sine function is the height, or relation to the x-axis, is the distance from the x-axis as a point goes around the unit circle. And what's cosine? Well, cosine, the cosine function is the distance from the y-axis as a point goes around the unit circle. And this is kind of cool. Let's think about this for a second. I want you to start. So what we can do is, I'm jump ahead a little bit here, but we could, let's make a graph of sine. So now what I'm going to do is, we know that we have sine. So this is the x and the y axis, right? We see that as it moves the height. Where does it start? Let's bring the point back down here. We start here. So this is 0, 1, right? So the height is 0. It moves up to 1. It moves down to 0. It moves down to -1. It comes back to 0. Nice. Let's make a graph for cosine. So cosine is the distance from the y-axis. So it's starting all the way here. This is a distance of 1, right? Let's make it's starting at 1. After 90 degrees, it comes back to 0. Another 90 degrees, it's now so far, it's -1 away, right? Now, another 90 degrees, it comes back to the y-axis. And then another 90 degrees, it comes back to 1. So this is our sine graph. This is our cosine graph. Once again, sine is like the height above the x-axis, and cosine is the distance away from the y-axis. And now we're introducing directed distances. Now this is kind of cool. So let's explore this idea a little bit more. So, so let's start over again. So, how are we doing for time? 8:49, perfect. Okay, so some examples. With my sheet. Okay, so I say sketch sine of 1.2. And this is right out of the book. So you're like, fine, I have a unit circle. I have a radian measure of 1.2. I know that 0 is 0, and I know that pi over 2 is 1.57. So I know this rotation, I know a rotation of 1.2 is kind of right here. Now the question is, what is the sine of 1.2? Well, we said the sine of 1.2 is the height away. So this length, whatever it is, that is the sine of 1.2. Let's try another one. The cosine of 6. The cosine of 6. So you're like, okay, this is fine, I got this. I have my unit circle. I know that a full rotation is 2 pi, or 3.28. Therefore, I know that a rotation of 6 takes me somewhere in the 4th quadrant. This is a rotation of 6, okay? This is 6. The question is, what is the cosine of 6? Well, the cosine is the distance from the x-axis. This length, whatever it is the cosine of 6. Last one, cosine of 2.4. Last one, cosine of 2.4. Let's see, cosine of 2.4. Fine, same thing. You do you're in a circle, right? And you say, what is the rotation that represents 2.4? Well, I know that pi is 3.14, and I know that pi over 2 is 1.57. So you know what? I know it's somewhere here in the second quadrant. Not really sure. This is a sketch. I know it's here. So the question is, what is the cosine of 2.4? Well, once again, it's the distance. And so it's the distance. So that length, that directed distance represents the cosine of 2.4. Let's just review something you might have learned last year. This height is positive because sine is positive in the first. This length is positive because cosine is positive in the fourth. This length is negative because cosine is negative in the second. Okay? Let's continue. Okay, let's pick up where we left off because I got a little flustered. So the first example, if the sine of theta is 0.6, what is the sine of pi, or 180, minus theta? So the idea is there's some angle, we don't know what it is, but its height at the unit circle is 0.6. So let's make a unit circle. Okay. We know there's two places that have a height of 0.6, right here and right here. So the question is, right? So this is the sine of theta is equal to 0.6, and same thing here. The sine of some theta is equal to 0.6. So the question is, if sine of theta, if we're taking 180 minus this theta. Okay, well, let's start with the first theta, which is kind of like this theta here. Now, it turns out that if this angle here, we see that actually from geometry, it's actually congruent to this angle here. So if I take the 180 and subtract off this rotation, it takes me here to sine of theta. Once again, 180 minus this rotation is sine of theta. So we got this first observation that the sine of 180 or pi minus theta, once again, 180 minus the pink takes us to this point, which has a height, which is sine of theta. They both have a height, or the sine is 0.6. Let's take the other arc. So we start here. Now, let's look at the other arc. So let's write another unit, just because once again, we had two answers for sine. Once we know that sine of 0.6 could be here or here. So let's take a look at this arc. So this rotation, right? This rotation has a height of 0.6. So the question is, what happens if I subtract this rotation from 180? Well, you can clearly see that, so you could, take this arc, but then I'm going to say, you know what? Due to reflection, I can, instead of write it like this, I can say, you know what? I could write that angle like this. And so I have 180 degrees minus this pink arc takes me right there. Well, that's also sine of theta. So we have our first identity, that the sine of 180 minus an angle is equal to the sine of the angle. You might have learned last year, and we're going to be talking about this. Now, first of all, sine is positive in the first and the second. So maybe you learned last year that like the sine of 60 is equal to the sine of 120. Or the sine of 45 is equal to the sine of 135. Nice. That's the first. Now, let's talk about next identity. Let's see what happens. Using the unit circle. Let's see what happens when I add 180 degrees. What happens when I add 180 degrees? So, well, this is very straightforward, right? So I have my unit circle. I still have the sine of theta is 0.6. Okay, right? And I'm rotating these points 180 degrees. Well, I'll use pink for the first rotation. That takes me around to right there. And let's use the green for the second rotation. Let's go around 180 degrees. That takes me right there. Interesting, right? So it turns out that, so where are we? Well, if this is 0.6, this is negative 0.6. So the sine of 100 of theta, if you add, it's equal to negative sine of theta. It's kind of cool, right? Once again, we started out, we know that theta has a height. There's a height of 0.6, so that's the sine of theta. Its height of 0.6. If I rotate it 180 degrees, both of these now have a height of negative 0.6. So the sine of theta plus pi is equal to negative sine of theta. Good, let's continue. Next example, let's use cosine now. The cosine of theta is equal to 0.7. And I want you to find the cosine of pi minus theta. And I want to know what happens to the cosine of theta plus pi. Okay, let's get our unit circles down. We have our first unit circle. We said that the cosine represents the distance from the y-axis. So there's two places that has a distance of 0.7. This distance right here is 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. And then here also, that rotation. So for example, like, I don't know, what is this? How do I get up there? What is this, like 30 degrees? I'm totally making that. I'm telling you, like 37 degrees? And therefore this is what? This is a 323 degrees. I don't know, but I do know that this is a theta, and that's also the same, like, so that's the idea, right? So, I'm sorry, no. And then this whole thing, right, whatever this theta is, whatever these thetas are, they're both 0.7 to the right of the y-axis. Okay, that's fine. What's the next thing we want to do? Well, let's think about this. So we're saying 180 minus that theta. Well, let's see. Well, we know if we we can see that this arc here could be this arc here. So, right? So 180 minus this pink, which is the same thing as a small arc, well, that takes us right here. Well, what's that? Well, that's negative cosine of theta, right? Because that's negative, this distance is negative 0.7. And what do you think about this? Well, what do you think about this? Well, this ends up going, what do you think about this? What do you think? Where does it take us there? Well, it ends up over here. 180, let's say. Well, we can actually do a full rotation right here. So we can do, like, it's almost like a 360, right? This is almost complete. So let's see. The full circle, it's almost like a full circle, right? 180, it's a full circle, but it kind of stops here. So again, it's up here, and the idea is this is negative 0.7, negative cosine theta. So we get the first identity is that cosine of 180 minus theta is equal to negative cosine of theta. What happens when we add 180? What happens if we add 180? Well, we already have our answer here. Let's see. What do you think? Well, if this is cosine of 0.7 and we add 180, where are we going? Well, we're going here, right? Let's do another diagram. Our first point is here, right? This has a distance of 0.7. We do a rotation of 180 degrees. Sorry, I'm right here. 180 degrees. It takes us right there. Negative 0.7. Or if we end up here and we do a full rotation of 180 degrees, it takes us right there. This is negative 0.7. So the cosine of 100 plus is also negative cosine theta. Interesting. Once again, you're just moving around the unit circle. It's helpful. It's really helpful. Let's go on. Let's do 90 degrees. Let's see what's going on with rotations of 90 degrees. How are we doing for time? Good. Now, you're getting these identities. You should know these, and you might know these. Let's go on. Let's see what happens. So, next example, the sine of theta equals 0.4. I want to know what the cosine of 90 minus theta is. Well, you could just plug this in the formula. I mean, you're given, but I want to use the unit circle. I find this unit, it's fascinating, so bear with me. Let's see about this. So, we have the unit circle. Let's start with this first point here, 0.4. We know we have another one. I'm just going to use this to make a point. So you know what? It's a little high up. I want it down here to make a point. So let's see. Whatever this rotation is, the sine is theta equals 0.4. Now the question is, what is this point here? So you might say, Mr. Adler, that's x comma, 0.4. Right? That's x comma 0.4. So this is the sine of theta, that's the cosine of theta, right? And I want to know what the cosine of 90 minus theta is. Okay, well, what do you think? What do you think? Well, if I can start at 90 and subtract off that theta, if I can figure out what that point is, that might be helpful. Well, we have some geometry from 9th grade. Well, actually, we have two things we spoke about. How do I get the reflection of, so I know that this point over, I know that this angle is 90 degrees. How do I get this point over here at 90 degrees? You would say, hey, Mr. Adler, why don't we just reflect it over the line y equals x? If I reflect this point over the line y equals x, then I reflect this whole triangle, right? So I have the point 0.4 comma x, right? And so what is the 0.4 now? And what is this point? And you can say, oh, you know what? That actually is 90 degrees minus the theta. And so if sine of theta is 0.4, the cosine of 90 minus theta is also equal to 0.4. And that's the idea. That's why we teach you this. Nice. Let's use the unit circle for the next thing. Cosine of 90 plus theta. Cosine of 90 plus theta. Well, let's see what's going on here. Let's see. So we know that sine of theta is 0.4. And the idea is we're rotating 90 degrees. Well, we learned if this point at 0.4, we know this point is x 0.4, correct? Well, we learned in geometry that we also learned in a rotations chapter that if we rotate a point 90 degrees, if you remember from the beginning, flip it and negate it. Well, let's see what this point is. Let's say this is 90 degrees, so this new point here is negative 0.4 x. And that makes sense, right? If that makes sense, let me use the green. In this point here, I don't know how far away it is from the x-axis, but I do know its height is 4. Now I know its distance from the x-axis is 4 to the left. Therefore, if the sine of theta is 0.4, the sine of 90 plus theta is negative sine, negative 0.4, or negative sine of theta. Once again, I took the point, which I didn't know the x value, but I did know how high it was because I was told the sine value. I rotated it 90 degrees along the unit circle, flip it and negate. So I have negative 4x. So now my new point, I don't know how high it is, but I do know how far away it is from the x-axis, which tells me my cosine. Because it's to the left, it's negative 0.4 or negative sine. Nice. Let's try that with sine. Let's see if we can come up with a relationship with sine. I know you can slip through this, but I just love this. I'm really into this. This is really cool. Let's do another one. Let's try another one. Knowing the unit circle, so let's try sine. Let's say you're told that the cosine of theta is equal to 0.9. Find the sine of 90 minus theta and the cosine of 90 plus theta. I should be saying pi over 2. I'm really bad with that. I'm an American. I don't speak many languages. So the idea is, I know that a lot of my students in international school speak many languages. And the idea is, when you're speaking in that language, you think in that language. But I'm constantly going back and forth between degrees and radians. It's a bad habit, I think. What's your opinion on that? Anyway, let's get a unit circle up here. Once again, it's all about geometry. I know the distance is 0.9, so it's down here, right? But we can look at the other example. I'm just going to stick with that first, just to make the point. I need to get up here. So let's see. If this is 0.9y, right? I'm going to reflect it up, and this is theta. If I reflect it up here, if I reflect it through the line y equals x, then I have a theta in here, right? Because these triangles are congruent. So this is theta, that's theta. And so whatever this arc is, it takes me to this point. So let's see, we have y 0.9. Nice. So if the cosine of theta is 0.9, the sine of 90 minus theta is also 0.9. What's going on with 90 plus? What's going on with 90 plus? Well, let's see. Well, I can use the same diagram if you can follow along. Let's see. If we take 90, so that negative 0.9y rotated 90 degrees, what does that become? Negative y 0.9. So the cosine of pi over 2 over theta is still, what is that? We wrote, oh, I'm sorry. Sorry about, yeah, it's 0.9. I apologize. Sorry. Nice. Okay, we're done with that. Let's move on. Go to the last part. If I ask you on the unit circle to what is if given sine of theta, find sine of theta and a cosine of beta, find sine of 2 pi plus theta and the cosine of 2 pi plus theta, and you look at this and you go, oh, you know what? Like any point takes me back to the same point. So sine of 2 theta equals sine of theta, and the cosine of 2 theta is actually equal to cosine of theta. And so we're introduced to this idea of a periodic function. This is a periodic function. So that the idea is that a function is taken back to itself. And we say that P, is the period. Okay. So for sine and cosine, the period is 2 pi. Okay, I just want to finish some last parts. First of all, let's use the unit circle to verify some things that we know. Let's call odd and even functions. So we have the unit circle, and let's look at sine of theta. Let's pick this height. Here's a rotation of theta, and it has a height of sine of theta, right? Now let's do sine of negative theta. Well, that's simply the same rotation, but clockwise. So it's this way. It's counter. Now it's still the same angle, and from geometry, we know that these triangles are congruent, which means this distance is the same distance. Directed, though, it's different. It's negative sine of theta. We just showed that sine of negative theta is equal to negative sine of theta. Oh, sorry. So we've just proven that sine is an odd function. Let's take a look at cosine. Cosine, once again, is the distance from the y-axis. Let's take another unit circle. Let's put that same angle. Here's the distance. So there's some angle, right? Here's cosine of theta. The question is, what happens when we have the cosine of negative theta? Well, same idea. It's like a reflection over, it's still the same distance. So this is negative theta, counterclockwise rotation, clockwise rotation. We still have the same, this is cosine theta, this is also cosine theta, hence the cosine of negative theta is equal to cosine of theta. We see here when we reflect the angle, the x value, the distance away from the y-axis does not change, hence cosine is an even function. Nice. Now, next, just quickly, from the unit circle, you can kind of start to make a sine wave, because if we said that the sine function is the distance above or below the x-axis, sorry, let me write that again. We can start at 0 if we want. We don't have to start at 0, but it's a nice place to start. And let's take a look at our sine wave. We'll use orange. For sine, we start, because this is 0, 1, we start at 0, we move up to 0, 1, right? So we go from 0 to 1, and then we're coming back down to the x-axis. So we're down to 0. And then what happens along our circle? Well, we're continuing around our journey. We end up down here at 0, negative 1. And then we come back to 1, 0. As we said, it's periodic. Excuse me. What's going on with cosine? Well, let's do cosine in blue. And we can do cosine on the same graph if we want. Cosine is the distance. Cosine is the distance. So we're starting at 1 away, and then we're moving closer, and then we're moving away from the y-axis, and then we're moving back to the y-axis, and then back 1 away. So we start at 1, 0, -1, 0, 1. Sorry, excuse me. So, another thing you might have noticed is something called the amplitude. The amplitude, so we have the amplitude, with amplitude, that's the distance from the midline until to a maximum. Once again, we want to take amplitude, we take it's 1/2 the distance between the max and the min. So our basic sine curves, a basic sine wave and a cosine wave has an amplitude of 1. Well, let's bring in the transformations unit to finish this off. Let's look at y equals sine of pi over 2 minus theta, or x. I should use theta, I'm sorry. So you might say, Mr. Adler, this kind of looks like a transformation, and it is a transformation. So let's figure it out. What's happening to this function? Well, we know we're starting off with sine, right? We know we have sine of theta, and then what happens? We have sine of negative theta. Well, it's rare that we know that when we negate the x values or the domain values, it's like reflecting over the y-axis. But you know what? We can make this a little easier on us because we know that this is an odd function, so we can write this as negative sine of theta, right? So the first transformation is simply a reflection over the x-axis. So let's reflect, reflect, reflect. And then the last transformation, you say, okay, move everything 90 degrees. Move everything 90 degrees to the right. Now, I'm going to do something a little interesting here. I'm just going to extend this up a little bit to make a point. Okay, last thing, shift this 90 degrees to the right. Well, if I move everything 90 degrees to the right, you notice something very interesting. This goes here, and this goes here, and this goes here, and this goes here, and this goes here. And you notice that the final transformation is cosine. And this is another proof. And this is the idea. So, once again, practice the unit circle. Remember, as the angle moves around, the cosine is the x values, the distance from the y-axis, and the sine is the y values, the height. And when you can follow along the unit circle, and you can find all the values for sine and cosine. See how you do. Good.